Okay, Geometry AB. We are moving on into Chapter 11 now that we have finished Chapter 10. And Chapter 11, Section 1 isn't anything really important and it doesn't work very well for e-learning. So we're going to skip right through it. We'll be okay, don't worry. And we're going to move right on to Section 11.2. And in Chapter 11, the big shift from Chapter 10 is that in Chapter 10 we were dealing with flat two-dimensional figures trying to find area for the most part. And now that we move into Chapter 11, we start dealing with three-dimensional figures. So anywhere you look around, as you're stuck at home right here, you're going to see three-dimensional shapes. So anything that has a length and a width and a height or a depth to it is going to be an example of something three-dimensional. So a lot of boxes that things get shipped in, anything you play sports with, a basketball or anything of that nature, all these things are three-dimensional objects. And what we're going to start doing in the beginning of Chapter 11 is talking about the concept of surface area of a three-dimensional solid. So what surface area really means is that we're taking something that is three-dimensional, that has a volume to it, but we're going to break it down flat and try to figure out the area of that particular region. So just like when you guys are taking a box out to the recycling bin, of course everybody knows, right, Mrs. Fontana, that you've got to take a box and break it down flat before you put it in the recycling bin. We're basically then measuring the surface area of that three-dimensional object now that it's been broken down to something two-dimensional. So we're going to do just surface area of prisms today. We'll come back and we'll do cylinders tomorrow. So the formula that we need for today is this one right here. That surface area of a prism is going to be equal to 2 times a capital B plus a capital P times H. All right, I'm getting ahead of myself just a little bit. A prism here, everybody, is a three-dimensional object, and these over here would all be examples of them. A prism is a three-dimensional object that has two congruent and parallel polygon bases on opposite sides of the figure. On this one right over here, you've got a triangle up here on the top of that figure and an identical triangle right down here on the bottom. And in between those two triangles, there are rectangles that connect all of the sides. So because this prism has triangles on the top and the bottom, that's why we call it a triangular prism. If we look at this second figure, there is a five-sided figure, a pentagon on the top, and a congruent pentagon on the bottom, parallel to the one on top, and rectangles connecting them all. So this is a pentagonal prism. And the third one is actually the one that you see most often. 99% of the things that are shipped in the world are shipped in this shaped box right here called a rectangular prism. There is a rectangle on the top of this figure, another rectangle on the bottom of this figure that's congruent and parallel to the first rectangle, and then a bunch of rectangles connecting them in between. So this is a rectangular prism. Now down here underneath that, this one right here is not quite a prism because it has a circular base here and another one here on the other side. That one's actually going to be a cylinder, which we'll talk about tomorrow. But this figure here has a triangle on the left and a congruent and parallel triangle on the right. So that is a triangular prism as well, just like this figure right here. And then this last one, we're actually going to do an example like this in a few minutes, has this weird shape, kind of a staircase thing on both ends of that figure. So this one is a prism as well. So that's what a prism is. Three-dimensional solid that's the same on one side as it is on the other, connected by rectangles. So as we go back to the formula here for surface area of a prism, this is what we came up with. A 2 times capital B, and right here we see that the capital B, you got to be careful to say this right. It doesn't just mean base the way that it did in Chapter 10 when we used a lowercase b. Using a capital B is significant because it means we're talking about the area of your base. And remember, every prism that we talked about here and here and here has two bases. One on one side of the figure and one on the opposite side of the figure. Sometimes it's top and bottom. Sometimes, like right down here, it's to the left and the right, but on opposite ends of the figure. So because there are always two bases in every prism, that's why we put a 2 in front of that B. That gives us the area of the top and of the bottom in this case. And then for what we call the lateral area, the area of all of those rectangles on the side put together, we get that area by multiplying P times H. And the P stands for the perimeter of your base. And the H is interesting. It stands for height, just like people would assume, but it's important that we realize we're talking about the height of the prism. And the difference between middle school and high school math here is that at this point we need to understand that height is not always measured vertically. Occasionally, height is going to get measured in a different direction. So, the important thing to understand here is that height is distance between your bases. Now, if I go back to this pentagonal prism right over here, everybody, since there's one base on the top and one base on the bottom, height is, like you would expect, measured vertically. That's your height right there. But if we look back at this figure right over here, this triangular prism, since we have a base on the left and a base on the right, height is now measured, again, as the distance between those bases. So it's kind of measured horizontally or diagonally in this case. I'm going to keep coming back to this definition over and over again throughout this section and in fact throughout the entire chapter. But we need to understand that at this level, height does not always mean straight up and down. Just like base doesn't always mean down on the bottom. Sometimes it does, but not always. So we have to understand these definitions moving forward. So there's our formula for surface area of a prism. So let's take a look at what's going on. Okay, so as we look at this problem right here, I designed this to look like something that you may have already dealt with earlier today, and that would be a cereal box. Which reminds me, I haven't had breakfast yet, and I'm hungry, so let's move this along. I was just guessing at the dimensions of a cereal box right here, but that seemed about accurate to me. Now, the first thing we ought to do is recognize that this shape, or this solid, is in fact a prism. It has a polygon base, and there's actually three different ways we could approach this, but let's make it easy. A polygon base down on the bottom of the figure upon which it's resting, and then a congruent and parallel polygon base up on the top. If you think about a cereal box, the bottom rectangle that it sits on is identical and parallel to the rectangle up on the top of that figure. So that tells us that for step one right here, guys, we can say that the surface area of our prism is equal to 2 times capital B, which means area of the base, plus capital P, the perimeter of the base, multiplied by the height of that figure. So that's always step one. Write down the formula. Step two, let's fill in what we know. Surface area is equal to 2 times, and now for capital B, we've got to figure out the area of this base down here on the bottom, or the one on the top, since they're identical. But on the bottom, we're dealing with a rectangle here, and we see that the width of that rectangle is 9, the height of that rectangle located right over here. Well, one nice thing about prisms is that every segment that's drawn parallel to one another ends up being congruent. This piece right up here is 2 inches long. So is this one, so is this one, and so is this one right here. So 2 inches is what we get for the height of that rectangular base. So for capital B, and it might not be a bad idea if you need to do this off to the side here, you might want to write this out somewhere, that capital B, which means area of the base, well, since that's a rectangle, we're just going to multiply 9 times 2 and get that capital B is equal to 18. Now, if we were going to nitpick here, that was 9 inches times 2 inches, so that gets us 18 square inches for the area of that base. So we're going to go ahead and write in 18 square inches where capital B went right there. All right, and this is why writing a formula is so important on these complicated problems. It kind of keeps you focused. All right, plus, the next thing we need to come up with is capital P. And if we go back to where we were a second ago, capital P stands for perimeter of the base. So we're still looking at the same shape right down here, but now we need perimeter. And if you recall, perimeter of any polygon is just the sum of all of its side lengths. So we have a 9-inch side here, a 2-inch side here, another 9 on the back, and another 2 on the side. What I always like to do here is to add together the length and the width. The 9 plus 2 gets us 11, and since there's another 9 and another 2, we just take that 11 times 2 to get 22 for our perimeter. So again, I did 9 plus 2 to get 11 and doubled that to get 22. Inches plus inches is just going to get you inches. Perimeter is a linear measurement, so its units don't get squared. And the last thing we need now is h. But again, trying to be careful right here, h, right here we said, represents the height of the prism. And that means distance between the two bases. Well, we identified our bases as being on the bottom and the top of this figure. So the height of this figure is the distance that in this case, not always, but in this case, runs vertically here. That's the height. And again, I look over here, that 12-inch measurement here is parallel to this h I had on this side. So sure enough, 12 inches is going to be the height of that prism. And now from here, guys, there's no reason we couldn't put all of this in the calculator here at once, but I don't have my calculator handy, so we'll do this one the hard way. The 2 times the 18 is going to get us a 36. This was square inches, no units on the 2 here, so that's 36 square inches. Add to that the 22 plus the 12. Oh boy, that's a 240. And another 24 right there is going to get us a 264. In units here, we are multiplying inches times inches, and that's going to get us square inches as well. And now we have 2 areas here. This is the area of the 2 bases put together. This is the area of the 4 rectangles going around the side from bottom to top. And notice that they have the same units, square inches and square inches. So we can add those 2 together, excuse me, and end up with a nice round sum of 300. Square inches plus square inches, when you add, the units stay the same, and we end up with 300 square inches for the surface area of that cereal box. Okay. Let's move on to one that's a little